So let me get my Google Meet here going for this to stream it. And we can be on our way. Look at that guy. You guys have dartboards at home that look like this at all?
I do.
Like this? You do? You hit the bullseye every time? Okay, kids. Section 1.4, more functions that we've talked about. The first section that we dealt with was absolute value functions. We talked about piecewise functions. Section 3 was inverse functions. So today, I better calibrate first. Today, what's your title of 1.4, kids?
Properties of exponents.
Properties of exponents. What do they look like in function form? Give me a show of hands. How many have heard of exponents before? You've all heard it before. Every single one of you should have heard it before, okay? Now, there's going to be some things in here that get a little trickier in terms of this, but I think you've got a good background knowledge in it. What do you know about exponents? Powers, bases. What do you know about it? One thing you know about it. Actually, give me two things that you know. One or two things that you know about exponents or powers or bases. Or if you had to describe to me what an exponent was, or what a power was, or what a base was, what would it be? What do you think, Ellie?
It multiplies a number by itself.
Multiplies a number by itself. So if I had like 3 to the 5th power, that would mean take 3 times itself. How many times, kids? 5. Okay, and you're exactly right there. Okay, so we want to take those ideas of powers and exponents and say, well, what happens when some different things start happening? And the goals are going to be pretty important to accomplish today. So in properties of exponents, the question we're trying to answer is how can you write general rules involving properties of exponents? Okay, general rules involving properties of exponents is what we're after. All right. So big goals to accomplish today. Most of the exponents you've always used are positive. So today we're going to start looking at what happens when the exponent is 0 and what happens when the exponent is negative. This might be kind of new for you today. I'm not 100% sure, but you may have had a little exposure to it. I'm just not sure how much. Second thing, we're going to use properties of exponents and then look at some real life problems involving exponents. So let's establish some vocabulary. Guys, power. What's vocabulary power mean? What's it say up here, kids? The what? Okay. Yep, the result of repeated multiplication of a base. So let me put this up here. If I put up here 3 to the 2nd power like this, 3 to the 2nd power is like the whole thing. What's that going to equal, guys, by the way? 9. Okay, and 3 to the 2nd power is equal to 9. It's 3 times 3. All right? So it's the result of this right here would be 9. Okay? So I think you get that. All right? In 3 to the 2nd power, which one is the exponent up there? The 2, right? Okay, so above, above 2 is my what again, kids? Okay. Now some people say that 2 is the power, kind of, but 3 to the 2nd, that whole expression is the power. This whole thing is the power up here. Okay. Well, guys, then base right here says it's the number being multiplied. So above, in the example above, what's the base? Okay, so above, you guys know this already. All right, I don't doubt that. Right? Want to make sure we establish this. Above 3 is the base. All right. Let me ask you this question. How many of you guys have heard of scientific notation? I think you've seen it. I think you've all heard of it. How many remember what it is? Andrew, what do you think, kiddo?
For like either really big numbers or really small numbers, it's 10 times of then one number, then a decimal, then the rest.
Okay, do you remember what that first Say that again.
10 to the 30 next probably.
Okay. You remember what that first number is written between, kids? That first number has to be a number between what and what? Anybody remember? Okay, let me tell you this right now. Okay, the first number is always a number between 1 and 10. So an example might be like 3.72, and then you're exactly right, times like 10 to some power. Okay? This would be an example right here. All right? This first number up here, I'm going to tell you right here, it can be 1, but must be less than what? The first number it can be 1, exactly 1, all right? But that first number really has to be a number between 1 and 10. And we'll look at this form here in a little bit, okay? Let me just throw an example up here on the board. Kids, what this is saying is this. This is kind of saying, you know what, this is 3.72 times 10 to the third. In decimal form, this is kind of telling me to move the decimal, how many places, kids? To the right. So if I had a number like this, let me just pick on a number like this. How about 45,620 here, kids? Okay? That's a number in decimal notation, and if I had asked you to write that number in scientific notation, my first question would be, where would you place the decimal point to make this big number a value, first of all, between 1 and 10? Where would that be? Where at, Logan? So this would be right here. So this would become 4 point what?
56.
And then times 10 to the, okay, how many places, if I put it right here, how many places to the right do I have to move it to where it really is? So this would be times 10 to the what? Okay, let me ask you this question. What if I had 0.0032? Where would you place the decimal to make that, first of all, between 1 and 10 in there? Where would you go with that, Andrew? Between the 3 and the 2. So this would be 3.2. Now, kids, here's the difference. This is going to become times 10 to, let's see, I want it here, but it's really where? So would that be times 10 to the third? Why negative 3? Say it again, Allie. Moving it backwards, moving it to the left. Exactly, okay? So this idea comes up with scientific notation, and that's what we're going to talk about with negative exponents and how we write rules for that kind of stuff today. But scientific notation is kind of a way that we introduce negative exponents and what they mean. So let's get started here, guys, on all of our properties. You don't need this down, okay? Do you guys have all the vocab examples written down right now? Okay. How many think it's too early on a Monday right now? I agree. All right, core concept. All these core concepts that are in here, these are kind of big ideas right here. All right. First core concept that we have, I'm going to kind of highlight these right here. First core concept up here says what, kids? Zero exponent. Okay. This says for any non-zero number a, it says a to any number. A can't be 0, but it says a to the 0 power is always going to equal what? 1. Okay. So if I had 7 to the 0 power, what would that equal? If I had 22 to the 0 power, what would that equal? If I had negative 66 to the 0 power, what's that going to equal? Anything to the 0 power will equal 1, with the exception of what, kids? What's it say right here? 0 to the 0 power is undefined. I have a question for you guys. Does anybody know why a number to the 0 power is equal to 1? Or have you just been told that before? You've been told that before? Okay, let me ask you this question. Let's see what you know. What's 7 divided by 7? 1, right? What's 5 over 5? What's 12 over 12? Okay, let me ask you this question. What's x divided by x? Okay, here's where things get kind of tricky. Because if you talked about this idea, if I have x to the third over x to the second like this, how many x's are really up top? How many x's are really in the bottom? How many x's cancel each other? So you're telling me that this is the same as x to the first power left over, is that correct? Okay. Well, so you're saying I could take 3 minus 2 to figure out what my new exponent would be in simplest form? Is that kind of what you're telling me? Well, let me ask you this question. Haven't you said one thing over the same thing is always equal to 1? So what if I had x to the third over x to the third? Aren't both of those equal to the same thing? One thing divided by the same thing would still be what value? 1, right? But by this logic right here, 3 minus 2 getting you x to the 1, you told me that this has got to be 1, but also this has got to equal x to, what's 3 minus 3 for a power? Right? So anything to the 0 power is going to equal what value? 1. Okay, don't forget that. All right? Don't forget that. All right, so let's go back here. Back to that core concept. There's another one down here. Right? These core concepts are kind of big ideas. Make sure you refer to them if you're not sure. Negative exponents. It says for any integer, non-zero number a to the negative n is the what? What's the word I'm going to underline here? Reciprocal of a to the n. So as an example, 4 to the negative 2 power, they say, is the same as 1 over what, kids? 4 to the second. Okay? So if you ever have a negative exponent like this, kids, it can be written as the reciprocal of this. Okay? So it says a to the negative n is equal to 1 over a to the n, where a not equal to 0. So if I had this, kids, 7 to the negative 5 power, this would equal what? Absolutely, Daisy. Thank you. 1 over 7 to the positive 5 power. Okay? Now I'm going to show you some shortcuts about negative exponents to try and make things easier as we start to look to simplify expressions. But guys, just know this. 7 to the negative 5, there's no fraction in this right here. So if I put this as fraction, there's like a 1 down here. And what happens when I flip that over? Well, this negative exponent turns to a what, kids? Positive exponent. Okay? All right, let's look at some examples here. Let's go to page 2. And on page 2, we're looking to simplify an expression. Okay, this says simplify the following expression. 4 times x to the 0. Here's the big idea you're going to run into a lot. It's going to say often to you guys this. It's often going to say, write your answer using only positive exponents there, okay? That's going to be the biggie for us. So let's look at the top here, kids. I have 4 times x to the, 0. There's that x to the 0 thing. Now, guys, you got to be careful on this. What would the x to the 0 power equal? How much? 1. So isn't the top really 4 times what? Okay? Now, here's how I'm going to change things for you. This is where things get a little tricky. I want you to think about negative exponents. Okay, do I have a negative exponent in there? Where is it at? Okay, listen to me, all right? Listen to me. This is not going to be told to you any other way than what they say. It's the reciprocal, okay? But think of the reciprocal as doing what? Okay. Property-wise, if you ever have expressions that are written in fraction form like this already, guys, on the bottom side, the y is having what kind of an exponent here? Okay. But we want that to be what kind of an exponent? Here's the deal. If it's just like an equation. Think of that fraction bar as like an equal sign. Okay? If I have something on one side of the equal bar and I want it on the opposite side, what do we have to do to the signs all the time? Flip them. It's the same thing with exponents. If I have y to the negative third on the bottom and I don't want a negative exponent, where would it be positive at then? On the opposite side. Okay? So if you ever have negative exponents here, kids, well, I don't want this to be negative, so I could make this positive, but I'm going to have to move it to which side of the fraction bar, kids? Top. Okay? So I've got to move that y to the negative third to the top, where it would become y to the third. Okay? Is anything left in the bottom? Absolutely not. So, what's 4 times 1 going to get you, kids? Y to the what? Okay. Have we simplified it? First question. Have we written it in such a simplest form where if I do have an exponent left, the exponent is positive? Okay, we're good then. All right, you guys try one on your own. I want you guys to simplify the following. Let's do this. Let's go 6. Oh, how about we pick on the best letter in the alphabet today? 6p to the negative 2 over, you like that best letter in the alphabet thing? Okay. Let's go 5. I'll try and trick you guys today. 5y to the 0. I think you guys are pretty smart, though. I think you'll get this. I want you to simplify that and write it in such a way that it's in simplest form. Oh, by the way, can I have negative exponents in the end? When you think you got it, or when you're done, just raise your hand when I know you're done. And just so I know you're done. I have a volunteer that maybe wants to talk me through this. So I sure as heck don't know what I'm doing. How about the 6? Is the 6 okay up top? Yep. How about that p to the negative 2? Is that a good thing or a bad thing? That p to the negative 2 is a bad thing, right? Where do you want to move that p to the negative 2? Well, I guess maybe the first question is, why is p to the negative 2 a bad thing? Negative exponent, so I can make it positive where else? Opposite side of the fraction mark, okay? So, okay, I can do some things with the p to the negative 2, it looks like. 5 is in good shape. 6 over 5 doesn't reduce at all. How about the y to the 0 power, kids? It's just 1. So do you guys agree at the bottom's really 5 times 1? So the bottom's really what value? 5. Okay, so really once I figure out that the bottom's 5, what are you going to put down there with the 5 afterwards? So what we end up with in simplest form, 6 is going to stay up top, 5 on the bottom because y to the 0 is 1, but we want this p to the negative 2 to be p to the positive 2, and that can only exist on the opposite side. So 6 over 5p squared would be simplest form there. Okay. You guys feel okay with that? Okay. First things first, if you have something to the 0 power, now I want you to understand something right here. Okay. Take a look at those two expressions I've just thrown up there. What's the difference, first of all, in the way they're written? Okay. So, in this one right here we talked about already, x to the 0 would be equal to what, kids? 1 times 4 then would become what? Okay, this is saying the whole thing to the 0 power. So this expression to the 0 power would equal, okay, see the difference between those two? This is only saying, this is really x to the 0. This is everything to the 0 power. So you might make a note of that somewhere on the side there, okay? So 0 negative property, or 0 negative exponents, I think you got a good start on them, all right? So let's start making it maybe a little more complicated. And honestly, if you've got that base down where you know what to do with 0 and negative exponents, this is actually pretty simple moving forward, right? So, some more core concepts, 3 big ideas that are going to show up for us today. Product of powers property, quotient of powers property, and power of a power property. All right? I'll blow this up here real quickly. Boom! All right. I blew it up. Did you hear that? Oh, never mind. Did I scare anybody there? Anybody jump? I wonder if they heard me over there. I love it. All right, let's talk about this one right here. We'll put some examples down. We'll try some together. It says product of powers property. First of all, it says let A be what kind of a number? Yeah, real. We're not talking about imaginary numbers yet. Okay, who's taking college prep with you next year already? Who decided that? Good. I'll have all of you. We'll talk about imaginary numbers. And let what? Let M be and M be what? Okay, to multiply powers with the same base, got to have the same base, what do? All right, so what this is saying is this. If you have 4 to the 6 times 4 to the 3rd, this would become what, kids? 4 to the 9th. Yeah, it's like multiplying 4 6s and then timesing it by 3 more. I'm sorry, it's multiplying by 6 4s, and then you're multiplying 3 more 4s. How many 4s would you have totally? So as an example, if I had 3 to the 7th times 3 times 3 to the 2nd. Be careful on this one, kids. That 3 in the middle, even though there's not an exponent, you imply there is a 1 there, right? Okay? What's this going to equal right here? 3 to the 10th power, yeah? There's really a 1 up here. All right? So realize that. So if I'm multiplying the same base, what do? Okay, then if multiplying meant add, then what's dividing going to mean? And we kind of talked about this already. Like 4 to the 6th over 4 to the 3rd here. This would become what? 4 to the 6th minus 3 or what? Okay, so it says let A be a non-zero real number and let M and N be integers. It says to divide powers with the same base. So dividing powers with the same base, you will subtract their exponents. So here's one for you. 7 to the 22nd power, 7 to the 5th. Do I have the same base in both the numerator and the denominator? Absolutely. So what are you going to do with the 22 and 5 here, kids? What's that going to simplify to then?
What is the 7? 7 to the
7 to the?
17.
Absolutely. Good. You guys are awesome. 7 to the 17th. Very good. Okay. Now, if there is one that's a little trickier, it's called power of a power product. Okay. It says let A and B, or sorry, let A be a real number and let M and N be integers. Okay. Power of a product property usually has parentheses in it. Okay. Power of a power property is going to usually have parentheses in it. So, in that example right up there, they say, well, what if I had 4 to the 6th in parentheses, and that's all to the what, kids? To the 3rd power out here. Okay, this is like saying 4 to the 6th times 4 to the 6th times 4 to the 6th. All right? But that's like 6 times 3 here, which is 4 to the what?
18.
So as an example, maybe I have 3 to the 2nd, like this, that whole base, 3 to the 2nd, all to the 5th power. Just let me show you what that means over here. That's like saying 3 to the 2nd times itself how many times? Well, based on our previous one right here, what's 2 plus 2 plus 2 plus 2 plus 2? 3 to the 10th, right? But couldn't I have just gotten that from 5 times what here, kids? When I bring something from the outside of parentheses to the inside, exponent-wise, you're going to multiply. And they say it's a power of a power. All right? So this would be 3 to the what, kids?
10.
3 to the 10th. All right. So let's see. That page is done. Let's try some examples, kids. I think you guys are good. How many are like, I'm on board with you right now, Parson. You're a little crazy, but I'm on board with you right now. Are you with me right now? You guys try this right now. You guys see, again, right using only what? Positive exponents. I'm going to give you 3 minutes and 14 seconds to try these three. See what you come up with, okay?
What?
Got them already loaded?
No.
Trying to wake you guys up. Is it working yet?
That one just says.
What do we look at?
All right, here we go. That was good. Gage, pat on the back right there. Give yourself a pat on the back. Attaboy. When you think you've got them, check with someone around you, okay? Guys, I think the first one is very easy. B and C are a little tricky. What I want to tell you is this. Don't lose concept of what it means to have positive exponents only when you're done, okay? Don't lose sight of having positive exponents only. All right, let's talk about the first one. Anybody want to volunteer for the first one? 3 to the second times 3 to the sixth. Write it as a power, but write it in simplest form there. What have we got here, kids? Dee, what do you think, kiddo?
3 to the 8?
3 to the 8. You say it like you're questioning 3 to the 8. Are you confident?
I question myself, so no.
That's all. I do that a lot too, but you're exactly. How many agree 3 to the 8? Yeah, exactly. Bases is straight. Got to add right here. So very good. All right, let's talk about the next one. I'm concerned about the next one. -4 to the second over -4 to the seventh. First of all, what would you do with the exponents? Subtract. So you would do 2 minus what, kids? 2 minus 7. This would be 2 minus 7. So this would be -4 to the 2 minus 7. But kids, what is 2 minus 7? So this is my -4 to the, and I'm done, right? What's wrong with it at this point? I have negative exponents, and it's specifically said at the top to make sure you do what? Right with positive. So what am I going to do? Well, there's really nothing down here but a 1. So what am I going to do with these two things? Flip them. So this would be 1 over -4 to what power, kids? Okay, and that goes back to the first core concept that we talked about how do you turn a negative exponent into a positive exponent. Okay, very good. How many have 1 over -4 to the 5th like that? Love it. Give me a show of hands. How many are at least on board as to how I got there? Okay, last one then, kids. This is like power inside of parentheses and a power outside. So what are you going to do here with the 4 and the -3, kids? So this becomes z to the -12 power, doesn't it? Am I done at that point? How should I express this with a positive exponent now, kids? What do you think, Dee?
Flip them, so it'd be 1 over z to the 12th power.
I love it. 1 over z to the 12th power. Okay? All right, guys, really one more core concept to talk about, and then I think that we'll get into some scientific notation, but I think we're going to maybe get through all the notes here. I don't think we're going to have time to start a quick quiz or anything like that today, but I will send out an online here in a little bit. Any questions about those three examples? A lot of times kids will get to this point and they forget to read this up here. So when you do get your online today, they're probably going to have you write your answers with what kind of exponent. Okay, if you're like, gosh, I know I'm doing this right, Carson, I know I have this right, check your exponents and see if you need to manipulate them a little bit to make those exponents that might be negative to be turned into a positive, all right? All right, kids, core concept. Power of a product property. This is an interesting one. Kids struggle with this one. If there's one that I thought was most difficult, this is the one. All right, so I'm going to put a little star by it. Twinkle, twinkle. All right, there it is. It says let A and B be real numbers and let M be an integer. It says to find a power of a product. Find the power of each factor and multiply. This is simply saying, guys, you know that 3 times 2 would be what? 3 times 2 would be...
6.
So this is like 6 to the 5th. But they're also saying, you know what? If you have one thing times another thing in parentheses, and I'll blow this up here again quickly. This is like taking a 5 into that 3 and a 5 into the 2. This is like 3 to the 5th times what? 2 to the 5th. Okay, so I'm going to give you an example I think would be a great example to look at. All right? And in fact, I'm going to use this 4x idea up here. An example might be something like 4 times x to the 3rd power. Okay? In parentheses, kids, you have 4 really times x, don't you? And you know what? Let's make this even trickier. Let's make this an x squared in here. Okay? Now, kids will look at that stuff and say, Carson, that's 4x to the 6th. And I'll be like, no, it's not. And let me tell you why. Because really, how many parts are being multiplied in here? 2. You got to bring this 3 into this 4, which is really 4 to what power? This is like 4 to the 3rd power times x to the 6th. Okay? Now, when I get done with something like that, it's like, okay, pump the brakes a little bit because we're not completely done. That 4 to the 3rd part, could we evaluate that? In other words, what is 4 times 4 times 4? What's 4 times 4 to start with? 16 times another 4. 64. Okay? Some people would say then this goes on to equal 64 times x to the 6th. So let's use some of those properties right here. Again, if you have something in parentheses, something times something else to a power right here, you got to distribute that exponent to everything that's getting multiplied, to each factor. So let's try this. Let's do letter A together, kids. This is going to become equal to -3 to the 3rd times x to the 3rd here. Okay, what is -3 to the 3rd? -3 times -3 would be... What's the negative times a negative start with? 9. +9 times one more -3 would make this what? Negative. So this is going to be in simplest form, -27 x to the 3rd. All right. Same thing happens if I'm dividing, kids. Like I took the 3 to the -3 and I took the 3 to the x right here. I have to take 4 into the numerator and I have to bring 4 down here to the denominator. So up top, what's this going to be, kids? What to the what? b to the 4th over -3 to what power? Okay, but I don't like that -3 to the 4th because that -3 to the 4th power could be evaluated. So let's think. -3 times -3 is +9. Times another -3 would be Negative 27 times another negative, I'm back to a positive. What's 27 times the 3? Negative 27 times negative 3. 81. Okay? And if you're not sure about what stuff numbers are, punch them in your calculator. If you ever have to take a negative value to a power, always put negative values in what, kids? Parentheses. Okay? This becomes b to the 4th over 81. You guys try C and D on your own. I'm curious to see. Ooh, D. Ooh, D. Ooh, D. Can I go over these with you, actually? Crazy shaking her head, yes. Okay, let's do this. Guys, how many parts are getting multiplied up here? 2 and what? So up top, this will be 2 to the 3rd times what? Over. All right. Help me. My North of Highway 3 math skills fail me today. What is 2 to the 3rd power up top? 8. So up top I have 8 times. You know what 5 to the 3rd power might equal? 125, Corbin. Very good. Am I done? Why am I done? Are all my exponents positive? We're in pretty good shape then, okay? And then they start throwing things in here like letter D. And letter D, I gotta tell you, make me mad. Okay. This is the same thing as what was up top. The only difference being is you've got what kind of an exponent. Let's cheat this first. Okay, do you guys agree this becomes 3 to the negative 2 power first? Times c to the negative 2 when I bring that into the numerator. You guys buying what I'm selling right there? Yes? No? Okay, how about the bottom? This will become 4 to the what? Okay, we've got a problem right off the bat, kids. And what is our problem now? All of our exponents are negative. So let's think about making those positive now after I've brought everything in. Guys, if I want to make all 3 of those exponents a positive, what do I have to do with all 3 parts? Okay, so what's on the top has to go to the bottom, and what's on the bottom must go to the top. So are you guys in agreement that this is now 4 squared over 3 squared c squared? Sounds like a new droid in a Star Wars movie. 3 squared c squared. All right, never mind. What's 4 squared up here then?
16.
What's the 3 squared in the bottom? Everything written with positive exponents? Okay. Now I want to show you maybe a shortcut to this. Can I show you a shortcut to this? All right, watch this right here. Guys, I knew right off the bat that this exponent was what? Okay. I could have switched right away and said, you know, this negative means take the reciprocal of what's inside here. So I could have written this as, if I wanted to do it this way, I could have called this 4 over 3c, not to the negative 2, but to the, and check it out. What would 4 to the 2nd be up top here? Isn't that what we had right there? Check it out. What's the 3 to the 2nd down here? Or 3c times 3c. Would the 3 times 3 make the 9 over here? Would the c times the c make the c squared right there? So if you see a negative exponent like this right here, and it's already in fractional form, what could you have done with this fraction right away? Flip it, but turn that exponent to a positive 2 right there. Okay? All right, kids. I think, yeah, I'm going to stop there. We're going to finish this up first thing tomorrow. Is that fair? I am going to send out the online today. I'm going to do that right now for you. That won't be, what is today? Monday, so it won't be due until Wednesday at 10 p.m. We'll finish this up here tomorrow.